So I want to say a quick word about scalar types. In Python, the scalar types that we're interested in are int, float, bool, string, none, and then the ones that we're not going to touch on in these materials are complex and bytes. Feel free to read up on those. And what we're considering here is what is the difference between a scalar type and let's say a collection type. And there are multiple ways that these are described, right? Scalar type, for our purposes, are values that sort of are a single entity, right? So we can imagine an integer. You know, when we declare an int, x gets 7. It's not like it's 7 and 3 and 4 and 9. It's only 7. Or if it's a float, 7.0. Or if it's a bool, it's true. There's a singleness to that, right? And when we operate on this, we're operating between a scalar value and, let's say, another scalar value. So x, 7, let's say x, and then y is 8. This is an operation between x and y. It's between two scalar values. We're going to get a scalar output of 56. So with all of these, in Python, these are all single values. And you might object a little bit to the concept of a string being a scalar type. And in many other languages, it's not. So let's say, am I a scalar? In Python, a string is considered to be a scalar type. It's considered to be a solid single value. And we can think about it. It's a little bit strange, but we can think about it as being that. But we can also sort of think about it as being a collection of letters. However, when we think about this string in relation to a list of letters and how we can modify a list of letters, but we cannot modify this string, then it becomes more clear that in Python, a string is a scalar type. Now, the other one that's a little bit strange here, none. None is a scalar type because it has a singleness of value, none. That value is none. It is the absence of a value, and that's how we define it. So we can consider that to be a scalar type as well. Now, to give some contrast, a collection is going to be a collection of either scalar types or collection types. So here's an int, here's a float, here's a string, here's none, and here's true. And this can be altered, as it turns out. A list is a collection type, but we can change these values. And when we change those values, it doesn't change the ID. With scalar types, if we make an assignment, right? If we assign 7 to x, and then we change x to a float, we're going to see a different ID here. And the reason we're seeing that is we're sort of destroying x and then giving it a new value that is the float of 7. And the ID of that in memory is not going to persist. So if I run this, we should see that these are two different IDs. And in general, we call this property immutable. So the scalar types in Python are immutable. And that's important to commit to memory. The scalar types in Python are immutable. Now, a collection type can be immutable, right? So a collection type can be mutable, such as a list. So we've got some mutable collection types, such as the list, dictionaries, are also mutable. But we can have an immutable collection type, and the example of that is the tuple, which will come along in a later lesson.